Hey everyone, how goes it? Welcome back to Computer Science 145. Today, we're going to talk about classes and objects. In a previous lecture, we started going over code organization. As we've started writing code, it's become more and more complex, and we need to better organize statements. That way, we can reuse parts of code, quickly find bugs and errors, and easily add or extend functionality. Java organizes software into first inside of projects, then inside of classes, and finally inside of methods. Today, we begin talking about classes. Classes are a way that we can create classifications of objects. Instances of a class are referred to as an object. The terms classes and objects are generally interchanged, but the way to always think about it is an object is an instance of a class. Classes provide a blueprint of a class of objects. Now, these refer to the shared qualities and characteristics of a given class of objects. In programming, classes combine data, which is referred to as attributes or properties, along with methods, which are the actions. In a previous lecture, we talked about how methods are verbs. Now, classes can be thought of as nouns. And remember, methods have to be grouped inside of classes. So, a class contains verbs. In other words, this noun contains the actions in which it can do. In order to best explore this concept, let's take a classification of objects that most people would be familiar with. Let's say that we're going to classify a cat. In terms of programming, if we create this classification called a cat, we need to think about what attributes that we're going to assign to it. In other words, what information do we want to keep track of for each one of the instances, in other words, for each one of the objects that are a cat? Well, one attribute that we can use is a name. We could say that these cats have names. Maybe we also want to keep track of the cat's weight. And finally, maybe we want to keep track of the number of legs that the cat has. These are just some of the attributes that we can assign to this classification that we call a cat. Now let's think about the actions. What verbs do cats usually do? Well, cats eat, cats sleep, and also cats destroy your stuff. Now, if we take this idea, remember, classes are just blueprints for objects. Objects are the instances of classes. So while we have this class called cat, if we're going to create a specific version of a cat, then maybe we have this, where let's say this is cat01, and its name is Mr. Flufferkins. Its weight, 8 pounds, and the number of legs, 4, and this cat has the actions, eat, sleep, and destroy your stuff. Now what if we had another cat? Well, this instance of a cat has a different name. Its name is Trisket. Its weight is 9.2 pounds, number of legs is 4. And maybe we have a third cat. Its name is Dr. Boots. Its weight is 8.6 pounds and number of legs is 4. Each one of these instances all have a name, weight, and number of legs, and they all share the same actions. But each one of them are different instances. They are different versions of this class. Whenever we create a class, that becomes a type, and this type is defined by the programmers. Data like variables and constants require a type followed by an identifier. So if we're declaring an instance of a class, we need the class type followed by an identifier. We've seen this many times before, and this is just one of many examples that we have here where we're declaring an instance of a random number generator that we call R. Another one would be scanner. Now, as a reminder, class identifiers hold a reference, in other words, a memory address to the contents in memory. Classes allow objects to be created dynamically in memory. Basically, what this means is we can start replicating code as we create new instances of these classes. In a previous lecture, we discussed that there's different sections of memory for a process. One section is called the call stack, and that was discussed in a previous lecture. Another section is called the heap, and this is generally where these classes are dynamically created. Dynamic allocation replicates the code written inside of the class in memory. Whenever we've used the reserved word new to create or construct an instance of a class, it replicates that code for that instance. So we've seen this many times before. As you can see here, if this class type, its ID is equal to the reserved word new following a constructor, which we're going to discuss a little bit later on in detail, then this replicates that in memory. And in fact, we've used that before. Going back to the random number generator, if we assign r equals new random, this is a call to its constructor, and that creates it inside of memory. Now, an object that has not been constructed has a special kind of memory address that is referred to as null. If an object is null, then it has not been created in memory. Now, before calling methods from any object, make sure to check if that object is null first. If that object is null and you try to call a method from it, it's going to result in a runtime error called a null pointer exception. We have used class types in the past, but now we need to start creating our own. In order to make this simple, here's how you can create a class in 7 easy steps. First, define the class. Then create its properties, instance variables, constants. Third, define the constructors, usually a default and parameterized constructor. 4, create accessors for every instance variable. 5, create mutators for every instance variable. 6, create the other methods like equals and toString. And 7, use the class to create instances that we call objects. Now, let's start creating a class. What we're going to do first is we're going to go over these steps and go back and forth from this to the code to demonstrate what's happening. So before we get to the code, let's look at the first step. When you define a class, this creates the type. So defining a class requires a couple of different parts. First is a scope, and generally it should be public. This is followed by the class identifier, and these identifiers follow the same general rules as a variable and method identifiers. The only main exception, and it's good programming practice to capitalize the first letter in class identifiers. Now, something that's very important in Java is the class identifier must match the file name. Also, in Java, there is one external class per file. Every time you need to create a new class, you generally need to create a new file with it. So, let's start creating that class cat. Going over to our project, here's what we're going to do first. We're going to create a new class just like we've done before, but this time we're going to call it cat. And we are not going to use the main method. So now this was pretty easy because this already created the class cat. It has defined this new classification of objects that we call a cat. I'm also going to include my name at the top here. And there we go. Now, along with this, I'm going to demonstrate what this does and how we can start using these classes, in other words, step 7, as we go along. So not only that, what I'm going to do is create another class, but with the main method. I'm going to create another class, and I'm going to call this, house of cats, include the main method. I'm going to go ahead and take out this comment, and make sure I put my name at the top here. So now, once you have defined that class, it becomes a type. So what I can do is use that type to create an instance that we call an object. So what I'm going to do is create an instance of that type cat. This is done the exact same way as we've created other variables. So I'm going to start with the type, cat. Then I'm going to follow it with the identifier cat01. And now this is an instance of the type cat. This is an object. However, this object is currently null. It hasn't been created in memory, and so far, this is all we can do with it. So let's go to the next step. Now, once you have defined the class, you should write the properties. The properties are the data that each object contains, and this can be constants or variables, and these are called instance variables. We're going to mostly focus on instance variables. Instance variable scope should always be private. The reason why we do this is because of this concept in object-oriented programming called encapsulation. Encapsulation means information hiding. So what we want to do is protect information. That way we preserve its integrity. We want to make sure that we error check all the properties. That way that this class or the instances that we call objects behave in the way that we intend. Now let's go ahead and define the properties for the cats. So once again, back inside of the cat class, we're going to create the properties name, weight, and number of legs. Now we're going to create the scope for each one of these as private. That way we can safeguard this information. So we're going to create private string name, private double weight, and private int number of legs. And there we go. We've created the properties for this cat. Now, as the scope of each one of these is private, well, we really can't do much with this right now. But we're going to create ways that way we can access and modify this information a little later on. But for right now, let's continue to the next step. Next, we need to write constructors. Constructors are very special kinds of methods that is used to create an instance or construct an instance of the class that's called an object. These are not like other methods because first of all, they do not have a return type. And also their identifier must match the class identifier. Now there's two different versions of constructors that we're really going to talk about. One is called the default constructor and the other one's called a parameterized constructor. Basically, the default constructor takes in no parameters. So this example right here is an example of the default constructor because there's no parameters. The purpose of a default constructor is to set all of the instance variables to some sort of default value. The other version is called a parameterized constructor, and the difference with this one is it does contain parameters. The rule of thumb is you create a parameter for each one of the instance variables. So as we have a name, a weight, and a number of legs, we need each one of those properties to be passed into this constructor so we can both create an instance of this object and also set that information correctly. Now in this version of a constructor, we say we call them mutators, and we'll discuss what those are later. So for right now, let's create some constructors. Now still inside a cat, let's create the default constructor. These are usually public. Now once again, constructors do not have a return type. Their identifier must match the class name. So to create the default constructor, it's public cat, no parameters. Then inside the body of this constructor, what we're going to do is set each one of the properties to some sort of default value. I'm going to use a very special reserved word called this. This refers to this instance. It is the self-referential pointer. So I want to get this name, so I'm going to call this dot name, and the default value for a cat's name, we'll just say none. Now we're going to do the same thing for the rest of the properties. This dot weight is equal to, let's say 1. And also this dot number of legs is equal to 4. Now that we've done this, let's actually use this version of a constructor. Going over to my code, inside the main method, we have declared an instance of this cat01. However, it has not been constructed, so its memory reference is currently null. However, if we were to construct it by calling cat01 is equal to Then we use the word new because we're creating a new instance. This is followed by the constructor, and I'm going to call the default constructor cat with no parameters. Now, after this is called, then this cat has been constructed with the properties where its name is none, its weight is 1, and the number of legs is 4. Let's take a quick look at that and what would happen inside of memory. So if we start right here, here's the thing. Inside of memory, the identifier currently has nothing in the contents. It's null. But as soon as we call this constructor, let's say that this object, this instance of this cat is created here, and its memory address is 40. Now for cat01, its name is none, its weight is set to 1, and its number of legs is set to 4. Now what's going to happen after we call the constructor is cat01 is going to be assigned the memory address, in other words 40. And the way that you can think about this is cat01 refers to that memory address, or it points to this memory address right here. Always keep in mind, when we talk about class types, the identifier only holds a memory address, and its contents, like the name, weight, and number of legs, is somewhere else in memory. Now going back to the code, we also have one other type of constructor called the parameterized constructor. So in order to create this parameterized constructor, we first start out with public cat. And once again, a constructor does not have a return type, and its name must match the class's name. Now for a parameterized constructor, what we're going to do is pass in information via the parameters for each one of the instance variables. So we're going to create string AN for a name, double AW for a weight, and also int AL number of legs. Now we're not going to write anything in the body of this quite yet, and we'll explain why later, but I'm just going to put a comment to do call mutators. Once we write those, we'll come back and fix this. So great. So far, we've created the type cat. We created the properties for the cat, and now we have a way to create it inside of memory by constructing it. However, there's not much that we can do with this because currently, there's no way to access this information and there's no way to modify that information. This leads us to the next step. Accessors are special kinds of method that provide access to the properties from outside of the class. Now, as the instance variables are defined as private, we cannot directly access this information. In this way, we got to create methods in order to gain access to that data. Now, accessors are sometimes called getters. It's a good idea to create an accessor for every instance variable. So the way that you would define an accessor is very formulaic. You would start out public, and whatever the instance variable type is, that's the return type. Then you use the word get, and then the instance variable's identifier, and then you return this dot, that instance variable. Now once again, the reserved word this is a way that we can gain access to the class's variables and methods, and it is the self-referential pointer. It's just good programming practice to use this. Now, let's create an accessor for all of our properties in our cat class. Let's create an accessor first for string name. So first we start out with public. Now the type is string, so we got to return type string. Then we use get, followed by the identifier name. An accessor does not have any parameters. We don't need to pass in additional information in order to get that property. After we define it, we just have to return this dot name. And now we have an accessor for the name. Now let's create an accessor for the weight. Public double get weight. And I'm going to return this dot weight. Finally, public int get number of legs. And I'm going to return this dot number of legs. Now, accessors are fairly straightforward. They follow a general formula, and once again, they give access to this data from outside of this class. Let's see how that works. Going back to my main method, here's what I'm going to do. System.out.println. Let's go ahead and print out cat01.getName. Let's add a space. cat01.getWeight. Add another space. And add cat01.getNumberOfLegs. Just to see if this works. Running this. Sure enough, it set all the properties because we used the default constructor. None, 1, and 4. Now we have a way to access information that is built inside of this class, or for this instance of this class that we call an object. Well, this is great and all, but currently we have no way to modify this information. The cat's name is always going to be none, its weight's always going to be 1, and the number of legs is always going to be 4. So now we need a way to modify information. This is where mutators come into play. These methods allow properties to be modified from outside the class. Once again, instance variables are defined as private, so we can't directly modify this information. Mutators are sometimes referred to as setters because it is setting the information. Now, just like accessors, mutators have a very simple formula. They all start with public, followed by void. We're not returning information, we're modifying information. This is followed by set and then the instance variable ID. Now, for every one of the mutators, we do need parameters because we are modifying the data. Another important element of a mutator is we need to check for errors. We need to preserve the integrity of this data. So for passing in this information via a parameter, we got to make sure that parameter falls within the specifications of this class. So if you notice here, we generally have an if statement, and if this is true, in other words, there are no errors here, then we can safely set this instance variable to the parameter. It's a good idea to create a mutator for every one of the instance variables, just like an accessor. So now, let's create mutators for our cat. So let's go ahead and create a mutator for the name. We're going to create public void set. This is how mutators start out. Now what are we setting? The name. Setting the name to what? Well, we got to pass in information, string, and we'll just say AN, a name. Now you can name a cat whatever you want, but there is one type of error check I need to bring up. Strings are also class types. Something that we should ensure is this value has been constructed. In other words, AN is not null. So if AN is not null, hold on, but wait a second. I'm using not equals here. And this is a class type. This is an object. I'm not supposed to use double equals or not equals whenever it refers to a class. Except in this case, because what we're checking is not the contents, but its memory address. So, as long as this has been constructed, then we can safely set this.name is AN. Now, if that's not true, then what we're going to do is go ahead and set this.name, let's just set it to the default value of none. That way the name is at least set to something. Now let's create a mutator for weight. Public void set weight. Double AW. Now let's think about this. What is a valid weight for this cat? I'm just going to keep this simple and say that if AW is greater than, strictly greater than 0, then we consider it to be accurate. And if this is true, we're going to set this.weight is equal to AW. But otherwise, if that is not true, we're going to set this.weight is equal to the default weight of 1. Now finally, let's create the mutator for number of legs. Public void set. Name of this instance variable is number of legs, and we'll say int AL. Now, once again, we need to check the integrity of this. We don't want to set our instance variable value if this is invalid. So I'm going to first check if AL has to be greater than or equal to 0 and AL has to be less than or equal to 4. I would consider all of these to be valid. This dot number of legs is equal to AL. And if these were not true, let's just go ahead and set this dot number of legs is equal to 4, the default value. We had to create instance variable scope as private because we need to safeguard this information. Because we did that, we needed to give access through methods called accessors and allow modification of these properties through methods called mutators. We need to do this to ensure the integrity of this data because look right here about these number of legs. The thing is, if this was wrong, in other words, let's say that the number of legs was greater than 4, well, this would create an adorable but spider-like creature that I guess would be a cat. But even more terrifying, if the number of legs is assigned to something that is negative, that would indicate that we have this worm-like creature that looks like a cat that goes around consuming other cats' legs. I don't want to create that in my programming reality, so this is why I safe check it. This is why I care about the integrity of my code. Now beyond that, once we have our mutators, now what we need to do is call them from our parameterized constructor. So going up to our parameterized constructor, here's what I'm going to do. This dot set name AN. This dot set weight AW. And this dot set number of legs AL. The parameterized constructor allows us to create an instance of this class while also setting each one of its properties at the same time. It just makes coding a little more convenient. However, if we are setting these properties, we need to be able to confirm whether or not that data is valid. Well, we've already written those checks inside the mutators. Why not just reuse the mutators and do the exact same thing? Now that we've created all of this, let me show you what you can do with it. Going back to this house of cats, what I'm going to do is now use cat01 and I'm going to call set name. What's the name of this cat? Mr. Flufferkins. And let's say cat01.setWeight is equal to 8 pounds. Now, let's see what happens. I'm just going to basically recall the system.out.println to print out the name, weight, and the number of legs for this cat1, and running this. As you can see, initially, as it was created by the default constructor, its name was none, 1, and 4. But now, using the mutators on name and weight, its name is Mr. Flufferkins, its weight is 8, and the number of legs is still 4. So excellent, I created an instance of this cat, and I assigned a name, a weight, and a number of legs to it. Now let's do the exact same thing by creating another instance of that cat, but utilizing the parameterized constructor. Cat02 is equal to new cat. I'm going to call this cat Trisket. Its weight is going to be 9.2, number of legs is 4. Now this one uses the parameterized constructor. So let's see what happens if I print out its name, weight, and number of legs. Well, there you go. It sets the name, Trisket, its weight 9.2, number of legs is 4. So what we were able to do using the parameterized constructor was create a new instance of that cat while also setting the properties name, weight, and number of legs at the exact same time. Now the really cool thing about this that I have to bring up is everything that we have written inside of this cat class so far. Basically, all of the lines of code, all 66 lines of code that we currently have. This gets replicated 2 times over. We have dynamically allocated all of that information in memory. We didn't have to write it all over again because what we did was we created a class. Those classes can be dynamically allocated. It could be replicated inside of memory by calling these constructors. classes are a way that we can start creating nouns, and these nouns can be created over and over again without having to write additional code. So now we get to some of the other methods. There's two other methods that I really highly recommend always writing whenever we're defining a class. The first one is the equals method, and this checks to see if another instance of the same type has the exact same properties. So this kind of works like the string method equals. Now this has a general formula, public boolean, because true or false, does this instance equal another instance? And also we do need a parameter that's another instance of whatever this class is. Then we just return all the properties are equal to another instance's properties. Now one of the first checks you should make sure is check whether or not that other instance is not null first. If that other instance doesn't even exist, of course it's not equal to. This will also avoid a runtime error. Let's go ahead and see the dot equals method. So back inside of cat, here's the next method. Public boolean equals. What are we checking? Well, another cat. We'll say AC. So what we need to do is check if this cat's name, weight, and number of legs is equal to this other cat's name, weight, and number of legs. So we're going to create a compound Boolean expression. We're going to return. Now the first check. If we're using this as a parameter, if we're using a class type as a parameter, you should check whether or not this thing even exists. So I'm going to first check. Return AC is not equal to null. If AC is null, then it's going to go ahead and return false, and it doesn't even check the rest of the properties due to short circuiting. And I'm going to enter down to make this nice. Now I'm going to check this dot name. Now the name is a type string, and in order to check one string versus another, we need to use the method equals. Now what are we checking if it equals? When we need to get this other cat's name. Oh, wait a second, I just said it out loud. I could just use the accessor, so AC dot get name. So if this name is equal to the other cat's name, and now this dot weight. This is type double. This is a primitive type. We can use double equals here. Now we need to get the other cat's weight, AC dot get weight, and this dot number of legs is equal to AC dot get number of legs. Now, if this other cat is not null and every other property is equal to all of these properties, then yes, we can consider these two cats equal. I'll show a demonstration of this in a little bit. Let's take a look at another really super useful method. Another useful method is toString, and this returns a string that will be the values of all the properties concatenated together. If we're going to pass the ID of a class type into system.outPrint or println, then it does call the toString method. It's useful to write this, that way we can have it print out all of the properties, and this is really good for debugging. ToString is also very formulaic. Public, it needs to return a string, it's just called toString with no parameters, and then we just return all of the properties concatenated together into one big string. So now, creating the toString method, public string toString, we're just going to return a string with all the properties concatenated together. So I'm going to return this.name plus, let's just add a space, plus this.weight plus a space plus this.number of legs. And there we go. This is just really useful for debugging. Now let me show you how to use this. What I'm going to do, instead of using this system.out.println here for cat2, I'm going to comment it out, and I'm going to do this. System.out.println cat02. Watch what happens. It basically does the exact same thing. Now, once I put this inside of this print line, it actually calls the toString method, which returns the name plus a space, the weight plus a space, and the number of legs, which does the exact same thing here. Now that we've written those other useful methods, now we need to write the other methods that were originally defined for the cat. So what does a cat do? Well, it eats, it sleeps, and it destroys your stuff. So let's create public void eat. And let's just say every time it eats, this dot weight, I don't know, plus equals 1. That's not very accurate, but this is just kind of a playful example. Now let's also do public void sleep. Well, what happens when a cat sleeps? I don't know, it says ZZZ cat snore. Now what about public void destroy your stuff? So what does a cat do, or what does a cat think when it destroys your stuff? Well, maybe it says, I am become, its name, Destroyer of Worlds. Now that we have all of this written, I'm going to go back here and I'm going to show one other quick demonstration. This is where the concept of classes and objects can become very confusing. So let's first do this. Let's create another instance of a cat, cat03. And I'm going to construct this using the parameterized constructor. Its name is going to be Mr. Flufferkins. Okay, just like cat 1. Its weight is going to be 8, just like cat 1. And number of legs is going to be 4, just like cat 1. Now here's what I'm going to do. System.out.println. I'm going to print out cat01 dot equals cat02. Now, what do you think is going to print out when we compare cat 1 to cat 2? We're running this. Well, of course it prints out false. Because cat 2, its name is Triscuit, weight's 9.2, number of legs is 4. This is the only property that's equal. So, of course, this will print out false. Now let's try this. System.out.println cat01 dot equals cat03. Now what do you think is going to print out next? Running this. Well, of course, it prints out true. This is because all the properties of cat 1, Mr. Flufferkins 8, number of legs is 4, is the same thing as cat 3. Now watch this. System.out.println cat01 double equals cat03. What's going to print out here? Running this, it prints out false. Why did it print out false? Cat 3 has the exact same properties as cat 1, but why would this print out false? The reason is cat01 and cat03 only contain a memory address, a reference to the contents in memory. Despite them having the exact same properties, this is at a different memory address than this. This is why it would print out false. Whenever you are comparing class types, you need to use the method .equals to compare the contents, not the memory address. You should use double equals and not equals when it comes to a class type in reference to the memory address, and the most common one is checking whether or not it is null. Now let me show you something even stranger. Let's take cat03 and assign it to cat02. Okay, so did we create a new instance of a cat? Well, let me show you this. Cat02.setName, and we'll name this cat Dr. Boots. Now I'm going to call system.out.println cat03.getName. Now, if you remember, cat 3's name is Mr. Flufferkins. Now we assigned it to cat cat2, which if we assign it to cat2, shouldn't it be Triscuit? Oh, but wait a second, no, it's Dr. Boots. But we set cat02's name to Dr. Boots, so why is cat03's name also Dr. Boots? Whenever you assign these types, remember, this only contains a memory address. Whenever you assign it like this, you have not created a new instance. You have two identifiers, cat3 and cat2, refer to the same place in memory. By setting cat2's name, which refers to the same thing as cat3, now if I print out cat3, it's the same name. You have two identifiers referencing the same object in memory. The assignment operator does not create new instances of these objects. The only way to do that is using the word new, followed by a constructor. Now let's once again look at what I just did closer inside of memory. So this is what we originally had, and also just to add to it, once we have added all of those methods in there, then technically also in memory you have all of those methods. But to keep this simple, we're going to just omit those methods. Now augmenting this. Now also to keep this simple, I've omitted all the parts where we did the system.out.println, that way we can focus on the dot equals part, and also when we assigned one variable to another. So let's step through this. Once we enter here and we call set name, we set cat01's name to Mr. Flufferkins and its weight to 8. Then when we get to here, we first declare a new instance of this cat, which is going to be cat02. It's currently null. When it calls its constructor, it's going to automatically assign the name to Triscuit, 9.2 for the weight, and also 4 for the number of legs. Now once that happens and it's constructed cat02, the identifier gets assigned to 96, so you can think about that as pointing or referring to this memory. Then we move on to cat3. Now notice we have memory and more memory, but we also need even more memory. Now cat03 does the exact same thing, but let's say that its memory address is 120, its name is Mr. Flufferkins, weight is 8, and number of legs is 4. So now, if we look at the first two cats, cat1 and cat2, if we call dot equals, it's going to compare the name, which is not equal, the weight that is not equal, number of legs, which is equal, but since the rest of the properties were not equal, it's going to return false. Now if we compare cat1 and cat3, now notice, this is at 40, this is at 20, but the name is the same, the weight is the same, and the number of legs is the same, which is why this returns true. Now if we get to here, we're comparing cat01 and cat03, not the contents, but the memory addresses. 40 is not equal to 120, and this is why it returns false. Now let's look at this. When we assign cat3 to cat2, what actually happens is this. Cat3 now gets assigned to the memory address 96. So we have two different identifiers referring to the same place in memory. When I assign cat2's name to Dr. Boots, well, cat3 just refers to the same place in memory, and this is why when we get to system.out.println get name, it's also going to print out Dr. Boots. But what about this cat's instance? It no longer has a reference inside of memory, so what happens? Well, it simply gets deleted. To finish this out, identifiers for class types only contain a memory address. Multiple identifiers can reference the same address, in other words, the same object. New instances of classes can only be created by using constructors. Assigning one identifier of a class to another one does not create a clone. Now, Java is a memory-managed language, and it has this mechanism called a garbage collector. And whenever the reference to an object is lost, the garbage collector goes along and removes that information from memory. Classes are a way that we can start organizing code into what we can consider to be nouns. And these nouns have methods which are verbs, they are the actions. We're going to explore this concept in more detail later on, but with all that being said, I'll see you next time.